In the immense scope of the universe, there exists a star not at all like any other, a Goliath of the cosmos known as Betelgeuse. Yet, behind its glorious appearance lies a ticking delayed bomb, prepared to release an enormous event that will shape the very foundations of how we might interpret the world. How do you think mankind ought to prepare for such a significant occasion, and how precisely would Betelgeuse's explosion reshape our understanding of the universe? Join us as we unwind the secrets of Betelgeuse in the vast expanse of space, where stars are conceived, live, and ultimately disappear. There's one star that has been causing quite a stir among cosmologists, Betelgeuse, a major red supergiant found conspicuously in the constellation of Orion. Betelgeuse has continuously stirred our interest with its sharp red sparkle and its inclination to change in brilliance. However, of late, there have been several intriguing developments that have heightened our fascination. Betelgeuse is an absolute Goliath, multiple times bigger than our Sun. Imagine a star so colossal that if it took the Sun's position, its surface would stretch past the orbit of Mars, consuming Mercury, Venus, Earth, and Mars altogether. However, its monstrous size isn't just an unusual fact, it's a sign of where it stands in its life cycle. As a red supergiant, it is in its declining years, expanding and cooling off after a lifetime of fusing hydrogen into helium in its core. Betelgeuse, at around 8 to 8.5 million years old, may sound young compared to human standards, but in the universe of stars, it's ancient. It has witnessed countless magnificent displays throughout the years, born from the mystical fire of a cosmic nursery. It arose as a hot, iridescent blue star, radiating immense energy. Yet, as the years passed, the star underwent a significant transformation, growing into the immense red supergiant we marvel at today. This change is evidence of the relentless interplay of two sublime forces, nuclear fusion and gravity within the star's bubbling core. Hydrogen atoms fuse into helium, producing vast amounts of energy that power the star's brilliance. But as the star depletes its nuclear fuel, gravity applies its relentless force, causing its outer layers to swell outward in a planetary dance. Unlike the Sun, whose surface shines with searing yellow-white brightness, Betelgeuse's cooler temperatures emit a more subdued radiance, casting warmth and mystery into the universe. However, its story isn't merely one of static splendor, it is a narrative of transformation marked in the annals of human history. Ancient texts from various cultures mention Betelgeuse's shifting colors, with records of the star appearing yellow in ancient times before changing to its current dark red appearance. This shift offers a glimpse into its grand process, an unfolding journey that continues before our eyes. Amidst Betelgeuse's radiant beauty lies an intriguing fluctuation, a variability in brightness that has perplexed astronomers for years. As a semi-regular variable star, its brilliance level ebbs and flows in a mesmerizing earthly dance, projecting its light across the sky in a rhythmic beat. Its musical cycles, meticulously observed since the 19th century by astronomers like Sir John Herschel, unveil a superb movement that resonates through the record of time. Nonetheless, Betelgeuse's brilliant dance is not merely a tale of consistency, rather, it is an adventure of sporadic greatness, accentuated by unexpected twists in a cosmic spectacle that has shaken the foundations of galactic understanding. In late 2019, Betelgeuse revealed its extraordinary dimming, casting a veil of mystery over the night sky. This red supergiant, a celestial beacon in the Orion constellation, embarked on a journey of cosmic transformation, shedding its brilliant shroud over time. As the star's brightness diminished at an alarming rate, dimming by 0.1 magnitudes per day, it reached its lowest point in February 2020. This grand display, visible even to amateur astronomers, ignited a wave of speculation among scientists worldwide. While Betelgeuse's fluctuating brightness is entirely expected, the extent and duration of this dimming event left researchers grasping for answers. Was it nearing the brink of a catastrophic supernova explosion, or was this merely a temporary brilliance inconsistency bridging the vastness of space at the speed of light? Its splendid light left on a remarkable journey, traveling around 725 light-years before reaching our eyes. Amidst the vast variations of Betelgeuse's behavior lies a series of unanswered questions, inviting astronomers and skywatchers alike to ponder the mysteries of the universe in a quest to unravel the secrets of Betelgeuse's enigmatic conduct. Andrea Dupree, a respected associate director of the Center for Astrophysics at Harvard and Smithsonian, embarked on a cosmic venture with her team, equipped with the unparalleled capabilities of the Hubble Space Telescope. They initiated a 3-year endeavor to carefully examine the outer realms of this radiant beast. The observations offered a tantalizing glimpse into the dynamic interchange of its cosmic dance. Like a celestial heartbeat, it expands and contracts, coordinating a harmony of brilliant fluctuations. Taking advantage of Hubble's sensitivity to ultraviolet light, the researchers delved into the star's atmospheric complexities, revealing a captivating array of tumultuous convection cells. By examining a series of spectra captured throughout 2019 and 2020, Dupree and her team unveiled the intricate choreography of material within Betelgeuse's celestial realm. Focusing on magnesium-2 lines, they decoded the atmospheric dynamics, revealing material plunging at remarkable speeds of 200,000 miles per hour from the star's surface into its outer reaches. The cosmic ejection of hot, dense material extended across vast distances, signaling the onset of a brilliant dust cloud that enveloped Betelgeuse in its cosmic embrace. Dupree's measurements uncovered an unprecedented surge of material, suggesting that this stellar giant continues to astound and mystify as it dances through the cosmos, captivating our imaginations and reshaping our understanding of the universe. The norm exuded from Betelgeuse's southern half of the globe over 3 groundbreaking months. As the residue settled and rose up out of its enormous shroud, stargazers wondered about the heavenly scene lowered by the complex dance of heavenly powers that oversee our tremendous and wondrous universe. The critical mass loss from creepy juice, while normal for stars, was especially vital given its greatness, far exceeding the pace of mass loss seen in our Sun. This unexpected shedding of material, combined with the ensuing obscuring of its brilliance, ignited genuine conversation among space experts, overall energizing hypotheses about the star's destiny. Astronomers considered whether this dim event could bring the hotly anticipated display of a hair-raising blast, an occasion of unrivaled extent that would offer humankind a fantastic view to witness the birth and destruction of a heavenly Goliath. Yet, in the midst of the hypothesis and fervor, one question lingered. What does this dim light foretell for Betelgeuse's future? Is it an indication of an inevitable explosion of the star or simply a momentary inconsistency in the star's famous planetary excursion? Different hypotheses arose to make sense of the perplexing dim peculiarity. Some believe that the dim light signaled a crucial, deliberate ease in the blast cycle, powered by the overall conviction that Betelgeuse is approaching the finish of its existence. Others accepted that a thick dust cloud, possibly originating from the star, obscured its splendor from our natural perspective. The third hypothesis explored changes within its photosphere, the visible external layer of the star, suggesting that changes in its composition could influence its brilliance. To unravel the planet's challenges, astronomers turned to various observational methods, including spectroscopic investigations that revealed a noticeable diminishing in Betelgeuse's effective temperature. These studies uncovered an interesting disclosure: its dim light matched with a significant decrease in temperature, indicating the presence of an immense dim region on its surface. With every discovery, the planet's riddle regarding its dim event began to unwind, offering enticing insights into the convoluted workings of grand occurrences. Eventually, the mystery surrounding this phenomenal event was decoded with the important aid of the Space Telescope. Mankind's careful attention on the universe through its unsettled look unveiled the plausible impetus behind this dim light, a major blast of intensely hot material into the vast expanse of space. This ejected material combined to form a thick dust cloud, covering a fragment of its surface and subsequently reducing the amount of light reaching us from the star. This dust cloud was believed to have originated from superheated plasma emitting from a massive convection cell on the star's surface, later migrating through its burning atmosphere towards the outer cool layers. As this plasma cooled and diffused, it condensed into small dust particles, forming a cloak that obscured light from roughly a fourth of its broad surface. Hubble's bright light spectroscopic observations, which began in January 2019, played a crucial role in reconstructing the sequence of events leading to its dull light. These observations captured indications of thick, heated material flowing through the star's atmospheric layers in the months preceding the obscuring in December 2019. A series of ground-based telescopes also documented the star's slow dimming in brilliance, especially evident in its southern hemisphere. This material initially produced more brightness than its standard brilliance, but ultimately blended into a dim shaded cloud as it spread outward and cooled. The prevailing speculation suggested that this outflowing material and the ensuing development of the foreboding shadow were responsible for its sudden dim light. The size of this discharge was truly staggering, catapulting Betelgeuse into the spotlight. The star released an estimated 100 billion times the mass typically released in a normal colossal mass discharge, equivalent to several times the weight of our moon. This earth-shattering event wasn't just significant for Creepy Juice alone, it also offered substantial insights into our understanding of heavenly mechanics. But what does such a tremendous ejection of material mean for Betelgeuse and the broader theories surrounding the star's destiny? The repercussions are significant. Conventional theories propose that red supergiants like Betelgeuse consistently shed mass before their catastrophic end. However, the sheer size of this discharge challenged this idea, hinting at more complexities and perhaps an unpredictable final stage for these stars. Later studies considered the timing of such an event, suggesting that it could occur sooner than previously expected, potentially within years. As this enormous star travels through space at approximately 67,000 miles per hour relative to its surrounding environment, it creates a bow shock, akin to the wave formed by the bow of a moving boat. This extraordinary phenomenon arises as the star's outer layers interact with gases and dust, offering a stunning display that highlights the star's dynamic nature and its complex dance with the cosmos. Studying Betelgeuse's bow shock not only provides insights into its current condition but also enhances our understanding of how stars evolve and lose mass over time. However, Betelgeuse's recent behavior has raised eyebrows among astronomers. Observations have revealed that its surface has cooled and become less dense since the launch event, leaving the star in a problematic state even years later. Hydrodynamic simulations suggest a connection between the star's convective activities, the mass launch, and ensuing changes in pulsation modes. This ongoing instability raises questions about the internal mechanisms driving these changes and their potential future outcomes. Furthermore, Betelgeuse's observed rate of mass loss is significantly higher than that of many other stars, indicating a complex interplay of internal forces. The flow driving this mass loss is somewhat counteracted by the continuous dispersal of energy through shock heating and mass ejection. Such observations underscore the dynamic and somewhat eccentric nature of Betelgeuse's life cycle, prompting astronomers to rethink their models of stellar evolution. With all these dramatic changes, one may wonder, is Betelgeuse on the brink of a cosmic explosion? The possibility of Betelgeuse going supernova has intrigued astronomers for years. However, the exact timing of such an event remains uncertain. Recent studies speculate about the timing of such an occurrence, suggesting it may be sooner than previously thought, perhaps in just a few million years. While the specific timing of such an event remains uncertain, the new unprecedented mass launch has evidently shifted the discussion, indicating a more imminent end than previously believed. Theories now contend with the implications of this massive loss of material and what it means for the star's stability and future. However, as the galactic community focuses on Betelgeuse, another celestial event captivates our attention and offers a compelling comparison. Cosmic Explosion SN 2023. This amazing blast occurred in the universe, more chaotic 101, lovingly known as the Pinwheel Galaxy, found only 21 million light-years away. Discovered in May 2023, SN 2023 isn't your common cosmic explosion, it's the nearest one noticed in ongoing memory, giving a precious brief look into a star's emotional, terrific finale. The location of SN 2023 was an inestimable victory. Kayagaki, a praised beginner cosmologist known for his ability to find supernovae, previously detected this quickly lighting up spot on the edges of more chaotic 101, utilizing an unassuming 235mm telescope. Once he declared his revelation, the cosmic community jumped right into it. Telescopes around the globe, from those positioned on Earth's surface to the orbit of the Hubble Space Telescope, quickly pivoted to catch the initial exhibition of this infant cosmic explosion. the hurry to follow its brilliance curve gave significant insights into the blast's nature and the environment surrounding the doomed star. In the disturbed month following its revelation, SN 2023's behavior was painstakingly recorded. The cosmic explosion quickly changed from relative haziness to amazing peak splendor in only 5 days, before progressively blurring, losing 3 magnitudes of brilliance daily. Detailed analysis of its spectrum revealed various bright emission lines, proof of the rough interaction between the expanding cosmic explosion shock wave and the gas surrounding the star. This wasn't simply a star reaching the end of its life, it was a gigantic star collapsing under its weight as its atomic fuel was spent, with the outer layers bouncing back off the thick core in a stunning core collapse cosmic explosion. What makes SN 2023 especially interesting is the thick shell of gas surrounding it, fundamentally impacting the shock wave's departure from the star's center. 2 potential scenarios could explain this thick surrounding material: either a strong, steady wind had been shedding material from the star before the blast, or the star experienced occasional explosions, catapulting material into space. Regardless, it's estimated that the star shed up to a solar mass of material in the final 1 to 2 years of its life, showing that its concluding minutes were nowhere near quiet. Pinpointing the source of the SN 2023 blast has become a focal point of research, investigating the details of its parent star and the events leading up to its last eruption. Astronomers can refine their models of how stars evolve and the mechanics behind supernovae. These revelations offer direct insights into Betelgeuse's ongoing condition and its likely journey toward becoming a cosmic explosion, giving a clearer understanding of the signs to observe for and how to interpret the complex behaviors of this gigantic red giant. Research conducted by Japan's Tohoku University suggests that Betelgeuse could still be in the carbon-burning phase of its life cycle, which typically precedes a star's downfall. Yukita Seo, the lead scientist of the study, recommends that the star's core could implode within a few decades after the carbon supply is spent. However, researchers at Hungary's Konkoly Observatory suggested that Betelgeuse is still in an earlier element-burning stage. Regardless of these contrasting views, there's a general consensus that Betelgeuse is poised to be the next cosmic explosion in the Milky Way, although this disastrous event may not happen for another 100,000 years. Throughout history, observations of supernovae have yielded significant insights into the deaths of stars. The earliest confirmed record of one dates back to 185 CE, when a brilliant star appeared overhead, taking around 8 months to disappear. Since then, various notable cosmic explosions have been documented, including SN 1604, which was the brightest star ever recorded in our night sky, visible from different locations on Earth, SN 1054, which led to the formation of the Crab Nebula and remained visible in light for 23 days, and the last supernova observed in our Milky Way, SN 1640, which Johannes Kepler famously studied. More recently, SN 1987A detonated in the Large Magellanic Cloud, identified through neutrino emissions and observed across the entire electromagnetic spectrum just hours after its light reached Earth. These observations have been crucial in developing accurate models of supernova behavior and enhancing our understanding of their role in star formation. Betelgeuse's impending cosmic explosion belongs to a class called core collapse supernovae, which occur when massive stars exhaust their nuclear fuel and can no longer resist gravitational collapse. These supernovae are among the most powerful and destructive events in the universe. When Betelgeuse finally detonates, it will release an extraordinary amount of energy in just seconds, comparable to the energy our Sun emits over billions of years. The energy release will predominantly manifest as electromagnetic radiation, spanning from visible light to X-rays and gamma rays. However, the most immediate and observable effect of a Betelgeuse supernova would be an incredible light show lighting up our night sky. Additionally, witnessing the explosion of a blue star could reshape our understanding of how the universe expands and the mysterious force known as dark energy. In the late 1990s, researchers were astonished to discover that, rather than slowing down, the universe's expansion is accelerating, thanks to observations of distant exploding stars. The Betelgeuse supernova, being relatively close in the grand scheme of things, offers a valuable piece of the puzzle in understanding how quickly the universe is expanding and the role dark energy plays in driving this cosmic dance. It's like finding a crucial clue in a magnificent treasure hunt, propelling us closer to deciphering the enigmatic workings of the cosmos. Moreover, contemplating the potential repercussions of a Betelgeuse explosion on our modest planet raises fascinating questions. Might humanity someday be in peril? Luckily, the immense distance that separates us provides a comforting shield. Betelgeuse, at a stunning distance of 725 light-years away, lies over 4,067 trillion miles from Earth, like thinking about the immensity of an endless ocean. This vast radiant expanse acts as a safeguard, protecting us from any immediate harm caused by the explosion itself. It's as if Earth is nestled in a large shell, shielded from the grand fireworks by the mysterious distances of space. So, the Betelgeuse cosmic explosion is a magnificent and awe-inspiring spectacle, and Earth's safety remains comfortably assured in the grand tapestry of the universe.